Hey, grade 12s, I had a request to solve from our worksheet, page 1. How do you solve for question 2? Question 2 on page 1 of our KSP unit basically says, if the concentration of D is 2.00 times 10 to the minus 5 molar at equilibrium, find the KSP for D2A. Now, anytime we have to do any equilibrium problem, we start with the big 3 steps. Step 1 of the big 3 steps is our balanced equation. So we're going to start with our D2A, and it's going to break apart at equilibrium. So I'm going to use my two-way arrows because that tells me I have an equilibrium reaction. And from this formula, I can see that I'm going to have 2 D's and 1 A. The D, I've already been told, has a +1 charge, and the A then would have to have a -2. A balanced equation will balance not only in the number of each element, but also in the overall charge. 2 + 1 is +2, and -2 is 0 on the product side of the equation, and an overall charge of 0 on the reactant side of the equation. Now, D2A doesn't actually exist. This is just standing in for some random elements. So this is step 1 of my big 3. Step 2 is always my molar ratio. The molar ratio just has us look at the balancing. So we know that every time one of these breaks down, I'll get 2 D's and 1 A. So if X amount were to break down, I would get 2X amount of D and X amount of A. X on the reactant side of the equilibrium tells us the solubility, the amount that will decompose into ions. X's on the product side of our two-way arrows talk about the concentration of that ion at equilibrium. I'm going to leave just a little bit of space here. Step 3 of my big 3 steps is my KSP expression. My KSP expression is going to be the concentration of my D ion, which is +1 charge, squared, that's what I do with the 2, times the concentration of my A ion. And it's to the power of 1, and of course I don't have to write a 1 in chemistry. Now, of course, I can take and substitute these values directly into the brackets. I can put the 2x in here because we said the concentration of D was 2x. So I'm going to put 2x squared. And we said the concentration of A was x times x. Now remember, this 2 applies to both the 2 and to the x. So this is 4x squared times x is 4x cubed. So now we have taken and we have simplified this to a very simple math equation for us to use. At this point, all questions are the same, guys. Either I give you the KSP and say find x, or I've given you x and said find the KSP. This question says find the KSP, so I don't know this. I must know x. We were told the concentration of D is 2 times 10 to the minus 5. Let's write this down. The concentration of D ion is 2 times 10 to the minus 5. But right here, I said the concentration of D was 2x. If 2x is 2 times 10 to the minus 5, then x must be half of that. It would be 1.00 times 10 to the minus 5. This is the value for x that I'm going to substitute. So I'm going to have 4 times 1.00 times 10 to the minus 5 cubed. Okay. Correct order of operation says you cube this first and then multiply by 4. So on your calculators, you're going to have, and just practicing showing you how to use your calculators, although those of you who do a lot of exponents will already use your exponent rules, but just a little practice here. 1.00, I'm going to use the X button to the minus 5 because I don't want to write times 10 to the power of. That X button or EE button will actually do that for me. I am going to cube that, so I'm going to use my cubed button. And then I'm going to multiply that amount that I get times 4, and I'm going to get 4.00 times 10 to the minus 15. So this is the KSP for D2A at equilibrium.